All right. Thank you for coming to my talk in the morning. And this is Michael. I'm a co-founder and CEO of Brevis. At Brevis, what we're building is what we call the infinite compute layer for Web3, and really for everything. But before I dive into what we're exactly building, let me just kind of quickly go through the problem and the challenge we're trying to solve here. So blockchains themselves are often marketed as world computers, but if you look close at them, they're actually pretty crappy computers. It cannot run faster than server, and the execution expenses is super expensive. Now, you may ask, okay, wait. So like we have all these progresses over the last couple of years on layer 2 scaling, on scalability research. We should be able to just run any kind of computation on chain today, right? Well, unfortunately, that is not the case. And let me give you a very simple example here. So every one of you probably used centralized exchanges in the past. In every centralized exchange, you all have the same feature, which is trading volume-based transaction fee discount. If you traded a lot in this month, next month you get a trading fee discount. This feature is a great feature. It retains the user for the exchange and it boosts revenue. But if you look at DEXs today, like until very recently, you don't have any DEXs that has this very simple, very useful feature. Why is that? Well, it is not because they don't want to add this feature. It's just because that to add this feature in your smart contract, to allow smart contract to have access to historical on-chain data and run this kind of computation, run this very conceptually simple computation, it will directly bankrupt you in gas fee. This is where we are in blockchain computation constraints and limits. So why is that? Well, turns out that fundamentally, blockchains are actually limited by the form of computing it is using right now, which is like a very simple form of computing. In blockchain, what we do is we call distributed consensus, right? So like we have hundreds of thousands of nodes and even millions of nodes reaching agreement on certain result of the computation, right? Let's give a very simple example here. Let's say we have two nodes in the network, Alice and Bob. Alice is trying to compute the result of the multiplication equation, and she spent all the computation power to do it. How can Bob be convinced the same? Well, there's only way right now to do that is the Bob to do the same kind of computation again. So Bob spent the same amount of computation power, and the way we do this is a recomputation equals to verification. The problem here is that you have like one node that is doing the computation, and you have millions of nodes that repeat the same kind of computation again and again and again. And that is fundamentally why blockchain computation is expensive. So how do we solve that? Well, we solve that by doing something called a verifiable computing. So in verifiable computing, you have two different roles in the entire computation process. Alice here become something called a prover. So Alice is not only just doing the computation, but also generate a magical piece of things called zero-knowledge proof. This piece of proof can be used to send to anyone. And in this case, Bob become a verifier to verify the computation is actually done correctly. The nice thing about ZK proof is that the computation cost you need to verify the proof is tiny comparing to the original computation itself. And the cool thing here is that no matter how complex the original computation is, you can always get the same amount of computation cost for verifying the proof. So now we decouple the process from computation to verification. And with this kind of a capability, what you can do is that you can actually offload a lot of very complex computation from blockchain to a verifiable computation environment, and then kind of just to do the computation verification on blockchain itself. Right, so why this is important is because Brevis is actually building on top of this new paradigm for computing, where you can enable infinite scalability on blockchain and reach kind of a centralized Web 2 like user experience for many of the blockchain applications, and there are applicability in AI and Web 2 world as well. So let me focus on blockchain use cases for Brevis today. For blockchain, how can you use Brevis? Is that for very complex and data-heavy computation, you don't need to do it on blockchain anymore. You can just offload it to Brevis. Brevis is going to do the computation itself, but also generate a ZK proof. The ZK proof is going to be submitted back to the blockchain, where smart contracts themselves can verify the proof easily and cheaply. So now with this kind of a new circle of computation, you can allow blockchain itself to tap into infinite amount of computation power that were not available today. So Brevis is not theoretical. So we have like numerous partners that are already using Brevis in live production use cases today. So we partner with some of the biggest names in the space, like MetaMask, PancakeSwap, QuickSwap, Sina, Beefy. Many of the newly launched the stable token protocols, OpenEden, Euro, and Linea. So we're partnering a very diverse set of use cases to help them grow the ecosystem, to help them build intelligent DeFi application use cases. So let me give a few kind of a quick example here. So recently we launched the Linea Ignition with Linea and a few other kind of the pretty kind of well-known DeFi partners. So the idea here is that you have a new chain ecosystem, right? So you want to kind of incentivize user to provide liquidity to use the different applications on chain. So you want to kind of distribute the tokens to them. So there are two ways you can do this. Well, the first is you can use a centralized service to distribute the token to them. And it runs the risk of compliance, security, and scalability. So what we do here is that we actually allow users themselves to generate a zero-knowledge proof to show that they have interacted with the blockchain and the protocols in such and such way. And the user themselves can just use the ZK proof to directly claim the token themselves in an entirely trust-free way. So this opens an entirely new paradigm of token distribution, which were not available in the past. So we also work with MetaMask to enable MetaMask card user kind of a engagement boost program by understanding and kind of letting user to prove their historical usage of MetaMask and their kind of a saving behavior on the chain. So another category of use case we do is something called intelligent DeFi. So this comes back to our earlier kind of example of user trading volume-based discount. So we actually launched this with PancakeSwap. So if you're trading on PancakeSwap today, on various different pools, like I think 6 pools right now, if you trade a lot, you can actually generate a ZK proof to show that you're a VIP trader and get dynamic trading fee discount going forward. So this is like the first time this is available, and we're launching with a lot more exchanges very soon. We have launched this with QuickSwap, with Athena, and with Uniswap very soon. So we're also helping to grow the entire RWA and the stable token ecosystem by, again, helping the stable token to embed better into the broader DeFi ecosystem by enabling something called a continuous protocol incentivization through ZK proofs. So users generate a ZK proof of their interaction with the protocol. So all the above mentioned examples are kind of a half on-chain, half off-chain design pattern, right? So like you still got a bunch of business logic running in an on-chain world. What we're seeing now is that a lot of these kind of use cases are actually going to move most of the computation logic and user experiences off-chain. So we're working with one of the leading perpetual swap exchanges today to enable a ZK-powered perpetual DEX. So with this kind of ZK-powered perpetual DEX, you can get a centralized exchange-like user experience, but the same level of security as Ethereum Layer 1. And at the same time, you get a benefit of privacy because you can hide your orders with dark pool orders. At the same time, kind of avoid like what we have seen so far on many of the perpetual DEXs, like liquidity assassination. Right. So this is like a new pattern of design we see that I believe is going to continue in the next 5 to 10 years. I believe that 99% of the computation happens in any kind of a blockchain application is going to happen off-chain, and it's going to happen in a verifiable way. Verified by ZK proof and hopefully by Brevis. So I talked a lot about what Brevis can enable and what partners we work with and all these kind of numbers. But what actually is inside the Brevis magic box? So in the center of the entire Brevis stack is something called Pico ZK VM. So Pico ZK VM is a RISC-V ISA general purpose ZK VM. Basically what it means, you can write any program you want and get it ZK approved. Pico is extremely developer friendly. So you don't need to understand anything about zero-knowledge proof. Like in the past, you need to kind of write mathematical equations to actually write ZK applications, but now you can just write simple Rust. So Pico is also blazing fast. Right now, on kind of a publicly available releases, we're the fastest ZK VM with a single GPU acceleration. And we're right now proving the entire Ethereum block execution. If you're following the entire kind of Ethereum ecosystem, you know that like the future of Ethereum layer 1 scalability depends on the fact that we can actually have zkVM generate proof for Ethereum underlying block execution in real time, which is like under 12 seconds. So, very soon, in the next few weeks, and a quick alpha leak, we're gonna announce something exciting called a Pico Prism. This is gonna be the world fastest zkVM ever existed. So Pico is fast, but it's not fast enough, because it is a general purpose zkVM, and in engineering design, we always have this trade-off of generality and performance. We know that a specialized circuit is high performance, but lacks programmability, so you cannot really build a lot of application using it. Well, where we want to operate as Brevis, as kind of a whole project, is that point. That is the better of the two worlds. So how do we achieve that? Well, modularity to the rescue. So Pico itself is extremely modular, so we can use the VM itself as a glue. And you can actually plug in a lot of different coprocessors into the glue so that it can further accelerate its computation for commonly used use cases with specialized ZK circuits. So there are many kind of coprocessors that we have, but just want to focus on one specific, very useful one. That is on-chain data ZK coprocessor that allows you to generate proof of user interaction in the past on-chain, like what is the historical on-chain interaction, historical on-chain data, and you can directly access them in your smart contract. So like with this kind of architecture for commonly used use cases, you can get another 2 order of magnitude performance boost in terms of cost and also in terms of latency, execution latency, in the entire kind of a ZK computation stack. So this is precisely why we have so many different application use cases that other kind of a ZK computing stack doesn't, because other computing stack only have like a general purpose ZK VM, and we have the way to actually plug in various different kind of coprocessors to enable application use cases in specific verticals and domains. And finally, I just want to mention that we want this entire ZK proving stack to be decentralized as well. Right, so like we now have the capability to prove Ethereum blocks in real time and scale like Ethereum to an infinite level. So the idea here is that you instead of relying on repeated computation for millions of nodes, in the Ethereum ecosystem, now you can have just like one single node does a huge amount of computation, and then generate a very tiny ZK proof that you can send to everyone in the network, and everyone else is just going to verify the proof easily. So what this means is that you basically have the capability to run kind of a Solana-like computation, but at an extremely decentralized network. So now the key thing is that, okay, we want to make sure the proof generation itself is not actually bottlenecked by a single centralized entity. And this is what we are building and releasing very soon, which is called a Pico Proving Net, that allows a decentralized and diverse set of participants to join the network and provide their computation power to build kind of to power the entire Brevis ecosystem applications. So yeah, with that, what we build at Brevis again is the infinite computing layer for Web3. It enables new design patterns, new applications with the power of general purpose ZK proof. Thank you.